The solutions to the practice problems for the exponent rules. The product rule was when you added exponents through expansion. I had x cubed and x to the fifth gives me x to the eighth. Here I would use a commutative property and reorder. 3 times 4 is 12. X, 7 and 2 make 9. Again, I would use my commutative property several times here to move x to the sixth. So I had 4, x to the eighth, y to the fourth. Don't forget there's a 1 there on that y. The power rule tells me to multiply. So that's going to give me x to the sixth. It just means I have x cubed twice, which means I have 6. Looking at 3x squared y to the fourth, be careful, it's not 3 times 3. It's 3x squared y to the fourth, and you need to write that down 3 times. So it's really 3 to the third power, or 3 times 3 is 9. 9 times 3 is 27. X to the sixth, there's where you multiply exponents. And again, you multiply exponents, y to the 12th. And you can look 4, 8, 12. If I was to expand, fractions are no different. I don't have a coefficient, so since these are all just exponents, I could multiply them. And if I wanted to, I could also show x squared y cubed 2 times, which means x to the fourth over y to the sixth. The quotient rule was subtraction of the powers. And so keeping my base, 6 minus 2 is x to the fourth. I have 6 x's in the numerator, 2, they all cancel, leaving me 4 in the numerator. Again, memorizing the rule, I would subtract 5 minus 2, and y is 4 minus 7, would give me x to the third, y to the negative 3. We do not like to have negative exponents, so we position them so they are positive. Another way to look at this problem is ask myself, I have 5 x's in the numerator, 2 in the denominator. They all cancel, leaving me 3 in the numerator. For my y's, I have 4 in the numerator being multiplied, 7 in the denominator. They're all going to cancel, leaving me 3 in the denominator. My 4 y's in the numerator and my 7 y's in the denominator, these all cancel and make 1, leaving me 3 in the denominator. When you have coefficients, you don't treat them like they have exponents. They are simply just a fraction that you need to simplify. 3/6 is the same as 1/2. 3 goes into 3 once, 3 goes into 6 twice. Looking at my x's, I have 8 in the numerator, 11 in the denominator, not even worrying about my subtraction property. They're all going to cancel, leaving me 3 in the denominator. And where did I get that? 8 minus 11. Looking at my y's, I'm going to get 2 in the numerator. 9 minus 7 is 2. Negative exponents, remember that's a change of position. It's in the exponent, which means multiplication. Multiplication and division work together. So this negative 2 just tells me it needs to go into the denominator. I had 3 down there. I brought 2 more. So now I have x to the fifth. In the second problem, it just means this needs to go to the numerator. I had 1. I brought 5 up. Now I have x to the sixth. If you'd like, you can put a 1 in the denominator. In the next problem, I look at my x's separately. These negative 2 just tells me change position, go to the numerator. I had 3, I brought 2 up. This y, power of negative 2, says drop to the denominator. I had already 1 down there, and I dropped 2. So I have x to the fifth, 3 and 2 more. Here I have 1 and 2 more, gives me y to the third in the denominator. And the power of 0, anything to the power of 0, is equal to 1. So even 2 to the 0 is equal to 1. X to the 0 is equal to 1. 3x, notice the parentheses mean everything in there has a power of 0. That's equal to 1. And in the last case, only the x has the power of 0, so the 3 stays. X to the power of 0 turns to a 1, and y squared. So this reduces to 3y squared.